to my channel Tech with SaaS. In this video, we will talk about microservices architecture. This is like a modern architecture which is being used nowadays a lot by companies. But let's discuss first the monolithic architecture that I had covered earlier. But in case you haven't gone through that video, let me just describe a bit about it so we can basically compare and contrast with the microservice architecture. So, what is a monolithic architecture? You can think this as a very big code base which has a lot of functionalities together. For example, if we have an e-commerce application that will have functionalities like authentication, payment, shopping cart, product information. So all these functionalities will be part of one single code base. It's not like that you have separate repositories for each functionality. So basically, you have one single unit and one single code base, and all the functionalities will reside in one code base. And suppose you want to do some changes in particular functionality, you have to basically test that same code base. I mean, you cannot basically separately test the code base and make sure that other things are not impacted. Maybe if the functionality is tightly coupled, so suppose you change something in payment service, so it might impact in the shopping cart service. So because they are part of one single code base, and these are basically functional calls, so you have to be very careful when you are basically modifying any code base in the monolithic architecture. And also when you're deploying the services, right, at that time also you have deploy as a single artifact. You cannot deploy these functionalities separately. Like in Java world, we use either WAR or ER to deploy our services, our application basically. So, and also sometimes if you want to scale one service, suppose you want to scale the payment service, it is not possible because payment service is part of the this big monolithic application. So you have to scale the whole functionality, whole application together. Then like we have this one tech stack. Like we cannot use multiple technologies together because we have just one runtime. So if you want to test out or try out the .NET, Java, Python together, it is not possible because it's only one code base. So you have to stick to one technology only. Then, like also, whenever we as a developer are changing any code base, we have to be very careful because maybe like you are doing small change in the product information application of functionality, but by mistake you can touch the payment functionality as well. So we have to be very careful about changing any code base in this architecture. So yeah, so these are the various attributes or properties of monolithic architecture. So you can see that a lot of problems are there. We can't scale the this functionalities separately, and we have to be like all the functionalities are tightly coupled. So to overcome all these issues, like microservices were evolved. So let's see what are those. Yeah, so basically, what is a microservice architecture? So, in microservices architecture, what happens that like if we have seen that in monolithic architecture, we have one code base and all applications, all functionalities are together in one code base. But in microservice architecture, what happens that all the functionalities are separated. I mean, in different code bases. So, suppose you have authentication service or shopping cart service, they are separate services. So there is no basically overlapping between them in terms of code base or functionality as well. So normally people think that micro means like small service. Small, I mean, it might be small, it might be big, it depends on your business functionality. But the core idea behind microservices architecture is that the functionality is separate. There is a this functionality is not basically combined with all the other modules. So suppose you have one module, one service, then you have that particular functionality in that. So suppose you want product info, then you have to call the product info service. So it's not like that you have to call other services. So basically, all the services are separated by these different functionalities. Maybe they might be smaller service or maybe bigger service, but ultimately the focus here is the code base is separate, functionality is separate. And suppose you want to utilize some functionality, you have to call that particular this service as a REST call or whatever the method you use. But the functionality is separate for each of the these modules. Then, if you look at the modern architecture, like whatever is deployed nowadays in the companies, so like we have this, suppose we have four services like service one, two, three, and four. Then we also have one API gateway. So API gateway is basically you can say a single point of contact for services. So a client or user will not directly call our microservices because they will not be maybe aware about our services. So they will call us like by one service, whatever like single URL, but our API gateway will aggregate all requests and responses from our microservices. So basically, API gateway does a lot of work like rate limiting, aggregation of responses. I mean, we'll see. I mean, I will try to make a video about this because it's a big topic, so I'll not go much inside that as of now. So yeah, then we also have this. Suppose now we have five services. So how do these services talk to each other? So like what is the inter-service communication architecture? So that is also one aspect of microservice architecture. Then this we have the service discovery. So suppose like we have a lot of microservices, then uh, how to find like what is the URL of the service, how to basically get about the information about services. So all these things are handled by the service discovery. So in this diagram, you can see that we have one like we have the client tier. Client tier is calling the API gateway. The API gateway is routing the request to the appropriate services and sending back the responses. Then whatever the service communication between the services, that is taken care by the inter-service communication, basically you can say module. So I mean, basically the idea here is services are separate, and they have their own functionality together. So it's not like that. It's like, I mean, they are not basically combined with each other. And now let's see what are the features or advantages of microservices. So, like I explained earlier that microservices are basically focused on one particular single functionality. So there is a separation of concern. So once service is supposed to basically give one functionality, we should not like mix the functionalities together in one service. So that will defeat the whole purpose. Then we like because all these services are separate and not like they have separate code base also. So they are basically loosely coupled. Like in monolithic architecture, all functionalities were together, so they are like very tightly coupled. But here, because we have many services, and all these services have different functionalities and they have different separate code bases, so they are loosely coupled. And also, they are technology agnostic. So suppose payment service you want to create in Java, or maybe shopping cart service you want to create in .NET. So it is possible here because the code base is different, deployment is different, and also runtime is different. So suppose you have the competence in the Java, .NET, whatever the tech stack you want to use, you can use. But in monolithic, it was not possible because like they had one code base. But here we have separate code base for different services. So yeah, we can develop our services into like using various technologies here. Then yeah, like development is independent. I mean, suppose there is some change in the payment service, so there is no way it's going to impact the shopping cart service. So the development is independent, and there is, I mean, there is not much risk of with interfering with other functionalities while we are updating or changing any one functionality. So these are the very good features of microservices, and I think because of these features, they are very popular nowadays. Yeah, then we can deploy services independently. Like nowadays, we are people are using the Docker Kubernetes, so that I will cover separately. But yeah, so by using those technologies, we can deploy services separately, and also we can scale them independently. So in monolithic architecture, we had to scale whole application together, but in microservice architecture, we can scale functionalities as per the requirement. So it's a good thing. We have more control over the scaling of the functionalities, then fault isolation. So, in case like an monolithic architecture, suppose there was any error in one particular service, so it might bring down whole app altogether because all functionalities were tightly coupled. But here, maybe a shopping cart service is down for some time, some error is coming, but product info will not be impacted because they are separate deployed and they are like very, I mean, loosely coupled. So development is separate, everything is separate. So there is no chance that all will go down in the at same time. So it's a good experience also for customer. Maybe for some time they cannot pay, but at least they can browse the website. They can add product to the shopping cart. So these are the various features of the microservices, which makes it very basically attractive for the developers and architects to adopt it. Now, the next biggest topic is the how do we communicate between the services? Like in monolithic architecture, it was very easy because mostly there were functional calls. Suppose shopping cart want to call the product info, so it can call by a method call basically. So functional call was there, but here uh, these are separate services. So it's not possible to call services by the by method call. So how do we do the inter-service communication in microservices? So there are various ways, various techniques for that. First way is the synchronous communication. In this communication, like every service is exposed as a like a REST service. Like we define the endpoints, URL endpoints. So suppose a shopping cart service want to talk to the product info service, so it will basically make a HTTP request to the product info service using its endpoints and get response from it. So and well, while it will call the product info service, it will wait for response also. So basically the real time request, and it's like waiting and basically blocking all the operations until it get response back from the calling service. So this is basically a synchronous communication, and this happens via REST endpoints. And I mean it's like yeah, I mean, it's basically API calls, we can say, in a nutshell. So by using API calls, we can communicate with other microservices. Second way is that we have the asynchronous communication way. In this, what we do, we have like message broker, and basically we use the MQs like queue, and it's like so it won't be in real time. There might be some delay in the response. So suppose product info service want to talk to the shopping cart service, so it will push a message to the queue, and then this message broker will push this message to the shopping cart service. Once it is processed, then this product info service might get response back as well. So in asynchronous communication, it's not, it may be near real time, but it's not properly, I mean, not fully real time. So maybe whatever services, like whatever functionalities is not urgently required by the client, we can use this communication. So yeah, so these two communications, like one is the REST-based communication, like API calls, like synchronous one, and second one is the message broker, like queue-based communication. We basically utilize in the microservices for the talking to the services from their point of view. But like nowadays, one more pattern is getting popular. That is the service mesh pattern. So in this, like what happens, like there are like few services like HashiCorp has some solutions like console solution. So what happens that in this like suppose you have three services. Suppose you are deploying three services in Docker environment. So in that, like every service have like one sidecar proxy, and then we also have a control panel. Basically, what happens, control plane, sorry. So what happens that suppose service here, right, in this diagram, suppose the service A want to talk to service B. So it will not directly call the service B via its REST endpoint, but we have this sidecar proxy basically set up in parallel to this service A. So this service A will call the sidecar proxy, and then the sidecar proxy of this service A will call the sidecar proxy of service B, and then this communication will happen over this channel. So it basically helps us that because like suppose some endpoints are changing or something is changing in the services, so authentication, authorization, all these overheads are basically taken care by the sidecar proxy. So services are very independent of each other. They don't need to basically maintain the endpoints of the calling services. So it's basically a very good configuration in terms of inter-service communication between microservices. So nowadays it is getting more and more popular. I will try to make a very detailed video on service mesh pattern because I think it is very important from the architecture interview pattern. So maybe yeah, look forward. I look forward to make a video on this. But for now, we can say that basically every service has a sidecar proxy, and that is basically a software like you get from a third-party software company, and that you install it, and that sidecar proxy will take care of the basically authentication, authorization, calling to other services. Okay, so all these aspects are taken care by that. Then we also have this control plane. So we basically control the communication between all these circuit proxies as well. Now let us understand the disadvantages of microservices. So maybe microservices are very important and they are like very useful, but there are some disadvantages as well. For example, it becomes very complex to maintain the microservices. When we develop the code in the monolithic architecture, so at that time we only have one repository maybe. So but when we use microservices, then we might have many repositories because depending upon the application to application. So at that time, maintaining multiple repositories, development, and basically the deployment become a tedious task. So you need a proper DevOps team, like you have to adopt the CI/CD methodology in terms of like properly maintaining all the repositories and for development and deployment of your application. So, and also in monolithic, normally what happens that we use only one tech stack. Like suppose you have a Java-based application or some other technology, but in microservices, we have option to use multiple technologies. Maybe one service you can build on Java, another you can build on Python. So also basically tech stack also increases. So I mean, if basically you have to maintain your tech stack and they are having knowledge of your resources, your I mean developers. So that also becomes challenging in long term. Second thing is that whatever the communication, right? So in monolithic applications, mostly there will be functional calls. So every functionality you can call locally. But here, because all those services reside in different clusters, then you have to make sure that you have a seamless inter-service communication. So sometime maybe another service is down and it's not responding properly and your service might keep calling it, so it might add like some kind of latency in the response back to customer, or maybe some delay in the response as well. So for that we have to adopt like a few framework, like as I mentioned earlier about that the service mesh or maybe we have to use the circuit breaker pattern. So I will try to basically make some videos on this as well in my upcoming series. Okay, so let's see what's next problem. Okay, like the same thing I mentioned earlier, like deployment and management of multiple repositories become tedious in long run, and debugging also. Like in monolithic application, you have one application. Maybe you can use your IDE. Like suppose you have Java application, then you can use Eclipse IDE to debug whole application in one shot. But here, like apps are in basically different code bases, so it's difficult to debug also. Maybe like if you have a cluster environment in that logs, like maybe scattered here and there. So if any issues are there, then you have to, I mean, you dig deeper into all servers to get the proper information. But yeah, there are some tools like Splunk and all. They are really helpful in debugging the issues. So yeah, so we can manage. Yeah. So okay, with this, like I think our videos, I think I covered most of the things they wanted to cover in this. So yeah, thank you all for watching. And yeah, please like, subscribe, comment,